Section 6.5, our objective today is I can state and apply the inequality theorems for two triangles. The two theorems that we're going to look at today are very long, but they do have names. So when we're going to use them, we can use the name instead of writing them out. The first theorem is called the side-angle-side inequality theorem. Okay, and it says, if two sides of one triangle are congruent to two sides of another triangle, but the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. Okay, so here's what it's saying. So we have two triangles, and we'll say this is triangle A, B, C, and this is triangle D, E, F, okay? And I know that AB is congruent to DE, and BC is congruent to EF. Okay, but I also know that angle B is greater than angle E, okay? And so what the theorem says then is then I know that segment AC is greater than segment DF. So here's what it says. If AB is congruent to DE and BC is congruent to EF, and angle B is greater than, or measure of angle B is greater than measure of angle E, then I conclude that the length of AC is greater than the length of DF. Okay. Second theorem is basically the converse of the first, but it's called the side-side-side inequality theorem. Okay, and it says if two sides of one triangle are congruent to two sides of another triangle, and the third side of the first triangle is longer than the third side of the second triangle, then the included angle of the first triangle is larger than the included angle of the second triangle. Okay. Right, so again, given two triangles, we'll call this A, B, C, and this D, E, and F. Okay, so in this one I know AB is congruent to DE, BC is congruent to EF, but I know that AC is greater than DF, or the length of AC is greater than the length of DF. Then I can conclude that angle B is greater than angle E. So here's what it says. If AB is congruent to DE and BC is congruent to EF, and the length of AC is greater than the length of DF, then measure of angle B has to be greater than measure of angle E. Alright, so let's look at some examples. Okay, so let's say example 1. Let's say I have triangle JKL and I have triangle MNO. And I know that JK is congruent to MN, and I know that JL is congruent to NO. Okay, and I know the length of LK is 5, and the length of OM is 6. Then I can say that measure of angle N has to be greater than measure of angle J by the side inequality theorem. Okay, so let's look at example 2. So in this one I have this triangle DGF, and I have segment GE, where E is a midpoint, so I know this is 4 and this is 4. This is angle 1, angle 2. This is 39 and this is 44. Okay. Alright, so I know that DE is congruent to EF, and I know that GE is congruent to itself. So I have this yellow triangle, and I have this teal triangle. Okay, but I know that measure of angle 2, because this angle is 39, this angle is 44, then I know angle 2 has to be 97, and therefore angle 1 has to be 83. And so then I know that the length of GF has to be greater than the length of DG. Okay, because I have this side congruent to itself, this congruent to this, and I know the included angle, so I know that this side has to be greater than this side by the side angle side inequality theorem. Okay, example 3. Okay, so let's say I have this picture, and I know that this is 10, this is 10, this is 7, and this is 7.2. And I have angle 1 and angle 2. Okay. Well, again, I have this triangle, and I have this triangle. And in these two triangles, I know this side's congruent to this side. I know this side's congruent to itself. So this is the included angle, and this is the included angle. The side opposite angle 2 is longer than the side opposite angle 1. So therefore, measure of angle 2 has to be greater than measure of angle 1. Okay? And that's by the side angle side inequality theorem. Okay, and let's do one more example. Number 4. Let's see. Let's do this one. Okay, so this is B, this is A, this is D, this is C. I know this side's congruent to this side. I know this angle is 29, this one is 32. And so I have this triangle and this triangle. And so I know that's congruent to itself. So by the side angle side inequality theorem, because this angle is greater than this angle, I know that this side must be greater than this side. So I know that length of DC has to be greater than length of AD.